welcome to part 7 of this video lecture series on Chapter 8. We're going to be talking now about the Virtual Data Center and working with iSCSI shared storage. Now, your web client, which I've shown in the previous video, and you will see in some of the demos, comes in the workspace in the web client has 3 basic panels on it: inventories, monitoring, and administration. What we're going to talk about in this section is things in the inventories panel. Now, all this information is most relevant to activity 8.9 in the text, which is part of lab 8.2 in MindTap, page 347 in the physical book, if you've got it. So what we're mostly talking about in a lot of ways is shared storage. Now, when you add hosts to a vServer data center, now the data center in this concept is not the physical plant. It is the an organizational unit, so to speak, for the iSCSI hosts that a vServer is managing. Of course, a given vCenter server can manage more than one data center. Now, when you add a host to the data center, the resources of that host are brought into the inventory of the data center. So its VMs come in, its devices come in, its storage in, its templates in. Now, there are certain kinds of shared devices like NAS and iSCSI that are actually managed by vCenter, accessed by vCenter through the iSCSI hosts themselves. So the vCenter server is not actually talking to the NAS, talking to the iSCSI SAN directly. It's kind of using the iSCSI hosts as an intermediary. There are other kinds of devices like distributed switches and clusters. In this case, what we mean by device, a distributed switch is really more of a construct, a software construct, not a physical device. These are managed by the vCenter server and available to the iSCSI host. Remember, a distributed switch is only possible on iSCSI hosts that are being managed by a vCenter server. Any iSCSI host can have local switches, but in order to have the same switch on many hosts without manually replicating it across all of them and manually replicating any changes across all of them, you have to use a distributed switch. Clusters are essentially groups of iSCSI hosts which will be managed together. Hosts and clusters are kind of related concepts. Okay, so with an iSCSI SAN, there are some basic moving parts here. One of these is the storage itself, logical unit numbers, or LUNs. The other piece of that puzzle are your storage processors, your SPs. Essentially, your LUNs, your extents, and of course, all this communication between the host and the SAN goes over TCP/IP. iSCSI is basically a SCSI over TCP/IP. It's like, not like NFS, really, because you're still acting like you're accessing a remote hard drive across the network, rather than treating something across the network as though it were part of your local drive. The two pieces of this puzzle are the iSCSI initiator and the iSCSI target. The iSCSI initiator is the host system. The target is the storage. So, like this. So you have your LUNs, your logical unit numbers, frequently VMFS. These are essentially groups of disk arrays. The things out here, your hosts don't know the internal contents of that disk array. All they know is there's a logical unit number. There's an extent out there. An extent is kind of, you can think of an extent as being roughly analogous to a physical storage device, even if it's a virtualized one. So when you're adding, say, when you've got a data store in an iSCSI host, and say, for example, it's a virtualized iSCSI host to begin with. You add another virtual hard drive. You have two options there. Either you can create a new data store for that new hard drive, or you can add that new hard drive to that existing data store by expanding the data store by adding an extent to it. Now, your storage processors on the disk array end, the iSCSI target end, listen for requests, shall we say, from your initiators. These initiators can either be a software construct, software-based iSCSI, or an HBA, a hardware bus adapter, like so. The software initiator, now this software initiator could also be an iSCSI driver in a physical system, but in our case it's VMware code built into the VM kernel. It allows your host to talk to your iSCSI using your standard network adapters. This allows you to use iSCSI without going to the trouble of buying the HBAs. An initiator will connect to your target by looking for the target, establishing a connection according to the target's requirements. The target will present the initiator with some LUNs, and the initiator will send SCSI commands, as in literally as if it were talking to a drive on a SCSI bus, and it will that data will be packaged across inside your TCP/IP and flow across the network. Your iSCSI host can discover these either dynamically or statically. Now, you should be aware that when you're using IP networks for iSCSI, the data being transported is not encrypted. So if you have really, really sensitive data, you may have to tunnel that. You may have to find some other way of tunneling that. Because the iSCSI SAN is not going to do it for you. Now, what you could do, of course, is run your iSCSI on a separate network. Use CHAP for your secure login. Remember, CHAP uses a three-way handshake to validate both the iSCSI target and the host. So there's mutual authentication going on here. The other thing about CHAP is that CHAP re-authenticates every once in a while. Also, there's a predefined private shared key, a shared secret, which doesn't actually pass across the network. Remember, and this I belabor this point because it is really important for you to understand how CHAP works, because this will come up again later in your networking courses for router protocol security, for point-to-point protocol security. This will come up again in your Security Plus course as well, if it hasn't already. So make sure you understand CHAP. It uses a shared secret. It passes a hash of the secret across the network. They both do the comparison, and if it's happy, great. Also, they re-authenticate every once in a while. It's not quite as it's not as stringent and cryptographically complex as, say, Kerberos, but it does have it can work. Kerberos can work in the same way with periodic re-authentication to make sure that there's not a. And the other thing that CHAP does is it makes replay attacks harder. So there's a lot of good stuff about the challenge handshake authentication protocol. So kind of looks like this. What you'll have here is you've got your host, your initiator. It talks to your distributed switch across the IP network to your SCSI target, your storage processor, and your storage processor will help you find the target inside the disk array. Now, if you do have a separate network for your iSCSI traffic, rather than build an individual host on each, build virtual switches on each host, you could use a distributed switch. That's the better plan. Attach it to each host that needs iSCSI, and activity 810 rather will show us how to do that. That'll probably be my next demo video. The next thing we're going to do is talk about VMFS file system data stores, which is VMFS is the file system that iSCSI uses for its data stores. Not NTFS, not ext2, not ext3, none of that. VMFS is its own thing, tailored to the particular needs of a virtualization platform. Thanks for watching, and we'll be right back.